Welcome to our ME 452 interim presentation on the analysis and redesign of a mini gumball machine by Team 17. Our production is a mini gumball machine for small gumballs or jelly beans. It is about 5 by 5 by 10 inches and holds up to 1.5 pounds of candy. Turning the knob activates the gear system to release the candy. Primary customers are businesses like arcades and restaurants, while secondary customers are families purchasing it for home use. The market value is around $1.2 billion. This diagram shows how the gumball machine dispenses candy from containing and guiding the gumballs to accepting coins, turning the knob, and opening the chute. The exploded view highlights key parts such as the cap, globe, gears, and base, showing how each connects and functions within the fully assembly.
Upon analyzing two possible assembly sequences for this product, we determined that the first possibility was having the body as the main component, with the base plate and door acting independently, and the subassemblies being the upper half of the body and the coin mechanism. The second possible sequence for assembly was having the base plate as the main component with just two subassemblies, one for the body, which included the door and coin mechanism, and the other for the upper half of the body. We used multiple criterion to compare the two different assembly sequences, including the ease of transferring and handling, locating parts, fastening or joining, testing subassemblies, and assembling in parallel. Although the two sequences did have very similar outcomes, sequence 2 overall performed better, so that is the assembly sequence that we have selected.
Here we have the first half of our bill of materials. In total, our gumball machine includes 21 components, with 3 of them being purchased and 18 needing to be machined. Most of our components are made with metals like aluminum alloy, steel alloy, and a popular zinc alloy for toys called Zamek. Most of our components are manufactured through die casting due to their more complex geometries. However, throughout our BOM, we also have components made by injection molding, compression and blow molding, and water jetting. Moving on to the second half of our bill of materials, we mostly have parts made of plastics with a few metal and one glass part. Overall, our product consists of 25 components, coming to a total cost of $26.58 per fully assembled gumball machine. Next, we will analyze the functionality of each component and its importance to price ratio.
This is our functional component mapping matrix. As you can see, it has all of the functives listed across the top, as well as all of the components listed along the side. It is important to note that all of the components have at least one function as illustrated by the X's in the table. This is our quad chart based on functional importance as well as manufacturing and assembly cost. Based upon this analysis, we will consider eliminating the inner rod as well as consider redesigning the coin mechanism with DfM and DFA in mind.
Moving on to the product family design, when taking a look at our primary and secondary customers, two functions change. One being the involvement of a coin, so that includes securing, accepting, routing, and depositing a coin, because when it comes to our secondary customers, the gumball machine will be more for entertainment and fun rather than for profit, so there's no need for a coin. And the second function changing includes containing gumballs, as in it should be easier to replenish and access the gumballs since it will be in a home and not unsupervised in a store. The modules that pertain to the function of the coin include the spider ring, coin mechanism release, and the coin mechanism front plate. And the modules pertaining to containing the gumballs include the cap and the globe.
The specific changes made to the original design to accommodate a more accessible candy replenishing and dispensing method are minimal when comparing the two versions for each customer group. The main change that would allow modularity between the two versions would be the addition of a thread at the top lip of the candy globe. This thread would remain unused but covered by the original cap, variant 1, which has a threaded screw on top that fastens to the inner rod. The second variant of the cap would not have the hole to accommodate the screw and would instead have a thread matching the one on the globe, as well as a hollow cylinder on the inside to ensure the inner rod remains in position once the cap is fastened. As a primary group of the product is businesses, variant 1 of the mini gumball machine is coin operated and only allows the dispensation of candy when a coin keeps the mechanism release lifted, dropping the inserted coins into the body of the machine after the wheel turns and releases the specified amount of candy. The coins can then be retrieved by separating the body from the base via a screw at the bottom. The second variant does away with this altogether, but retains the turning mechanism that spins the wheel and allows candy to fall. Both variants have very similar assembly sequences due to the minimalistic nature of the changes made. Thank you for watching our short presentation on our mini gumball machine.